Hello students, today I am starting with another topic in physical chemistry, that is electrochemistry. So in this session we are going through conductance, in conductance, specific conductance, equivalent conductance and molar conductance, their definitions and their SI units. Also conductivity cell and cell constant. We know that electrolyte solution conducts current, and the flow of current is due to migration of ions to the oppositely charged electrodes. So, the power of electrolyte to conduct electric current is termed as conductivity or conductance. Similar to conductors, electrolyte solution also offers some resistance to the flow of current. So, conductance is also defined as the reciprocal of resistance or offered by electrolyte solution for the flow of current. So reciprocal of resistance is also a conductance, and the unit of resistance is ohm. So it will be ohm inverse or called as mho, and the SI unit of conductance is Simon, denoted by S. If you take a conductor, the resistance R of a conductor is directly proportional to its length L and inversely proportional to the area of its cross section A. So resistance is proportional to L upon A. So the proportionality constant is rho, which is called specific resistance. So if length is 1 centimeter and area is 1 square centimeter, then resistance will be equal to specific resistance. So specific resistance is the resistance offered by a conductor of length, unit length 1 centimeter and area of 1 square centimeter. And the reciprocal of specific resistance is termed as specific conductance or specific conductivity. Since if the length is 1 centimeter and area is 1 square centimeter, it will be equal to volume of 1 centimeter cube. So specific conductance is defined as the conductance of 1 centimeter cube of a solution of an electrolyte. So it is due to the conductance of the ions present in 1 centimeter cube of the solution. So the specific conductance is denoted by the symbol small k known as kappa. So specific conductance is reciprocal of specific resistance rho. So from this expression we can see that 1 upon rho will be equal to 1 upon rho into L into A. So this will be the expression for specific conductance. So from this expression we can see what is the unit of specific conductance. So R expressed in ohms, length centimeter, area centimeter square, square centimeter, then ohm inverse. So centimeter 1 centimeter cancels, remaining is 1 upon centimeter, so it will be per centimeter. So unit of specific conductance is mho per centimeter, and the SI unit of specific conductance is Simon per meter. Now let us see what is equivalent conductance. We know that when a solution is prepared by dissolving 1 gram equivalent weight of electrolyte, then it undergoes complete dissociation to form ions. And the conductance of all the ions is equal to equivalent conductance. So thus, conductance of all the ions produced by 1 gram equivalent weight of an electrolyte in a given solution is known as equivalent conductance, and denoted by symbol lambda. And it is given by the relation lambda is equal to K into V, where K is specific conductance and V is the volume of the solution containing 1 gram equivalent of electrolyte. And since volume is inversely proportional to concentration, so V is given by 1 upon C. So equivalent conductance will be equal to specific conductance K upon concentration C. Suppose if C gram equivalent per liter is present, then volume containing 1 gram equivalent will be equal to 1000 upon C. So 1000 cm cube upon C. So substituting this value for V, so equivalent conductance will be equal to 1000 K upon C. So also if you see the unit of equivalent conductance, so lambda equals K into V. Unit of specific conductance is per ohm, mho per centimeter. For volume, centimeter cube per equivalent. So it will be equal to, so per centimeter, centimeter will be cancelled, remaining is centimeter square. So mho centimeter square and equivalent per, that is minus 1. So SI unit of equivalent conductance is Simon meter square per equivalent. Similarly, molar conductance, that is lambda m, is the conductance of all ions produced by 1 mole of a substance or 1 gram molecular weight of an electrolyte in a solution. So if we are having a solution containing 1 mole of an electrolyte, then on dissociation it will form an ion, it will form ions. So the conductance due to all the ions is molar conductance, and it is given by the relation lambda m equals specific conductance K into volume. So V is the volume of the solution containing 1 mole or 1 gram molecular mass of electrolyte. So V is equal to 1 upon C. So molar conductance will be equal to K upon C, specific conductance upon concentration. So if we see the unit for molar conductance, so lambda m equals K into V. Specific conductance has the unit of mho per centimeter. For volume, centimeter cube per mole. So it will be equal to mho centimeter square per mole. And the SI unit of molar conductance will be Simon meter square per mole. Now coming to the conductivity cell and cell constant. So conductivity cell is a special kind of cell which is used to determine the conductance, that is specific conductance of a solution. And the cell is made up of 2 platinum foil or platinum electrode which is coated with platinum black or platinized platinum electrode, and the distance between the 2 electrode is 1 centimeter, which is denoted by L, and the area of the electrode is A, which will be equal to 1 square centimeter. And these 2 electrodes are fused to a wire for external circuit which is enclosed in a glass tube, and this whole setup will be dipped in an electrolyte solution whose conductance is to be measured. And this conductivity cell measures the specific conductance of a solution. So specific conductance K will be equal to 1 upon R into L upon A, and for a given conductivity cell, the distance between the electrode L and area A will remain constant. So thus the ratio L upon A, which remains constant, is called cell constant. So cell constant is given by L upon A, and the unit for cell constant will be, so length in centimeter, area in centimeter square. So it will be 1 upon centimeter or per centimeter. And in SI unit, the cell constant unit will be per meter. Suppose we are having a conductivity cell in which the distance between the two platinum electrodes is 1.80 centimeter and the area of the electrode is 5.4 centimeter square. Then the cell constant will be L upon A. So it will be 2.75 centimeter upon 5.4 square centimeter. So which is equal to 0.5 per centimeter. So this is the value of cell constant. If we convert into SI unit, so it will be 0.5 into conversion factor per centimeter is 10 to the power of 2 per meter. So it will be 50 per meter. So with this I will conclude this session. Thank you.